So question 1 on the homework is the binomial distribution. You know that it needs to be between 3 and 7. So you want it to be less than or equal to 7, but more than 3. So the values that x could take would therefore be 4, 5, 6, or 7. So you need to work out the probability that it is less than or equal to 7. But that would also include 3, 2, 1 and 0, which we don't want. So you need to take away the probability of it being 3, 2, 1 and 0, and that would be the probability that it is less than or equal to 3. Because it's been a little while since you've done them, I'll just remind you how to work that out on your calculator. So you need to go to menu and 7, and then remember you've got them listed here. So you actually want the binomial CD, so press 1, and then you can either do the list or the variable. In this case I would do the variable one. X, because it's cumulative, these are all going to give you less than or equal to probability, so you just put in 7 here for x because you want less than or equal to 7. N is obviously this number here, so the 20, and then 0.41. So that is just going to give you the answer to this one here. You're then going to have to do the same thing for 3 and then take them away. The next part goes on to the actual hypothesis test. So it says here that the actually previous research suggests that it's 30% of customers will order a starter, and we know that it's a sample of 40. So straight away we know it's going to be binomial 40, and the probability is 30%, which is 0.3. So the null hypothesis then is just going to be, remember that just equals this probability here, so p equals 0.3, and then we're testing to see whether it has decreased, so therefore less than 0.3. So when they've given you something that's happened in the sample, you've just got to test what has happened. So in the sample of 40, it was 7 that ordered a starter, and you keep the sign the same as this, but put an equal underneath. So you would be testing the probability that it's less than or equal to 7. Using this distribution here, so very similar to what we did up here. You then get your answer, and it's at the 5% significance level, so you'd compare it to 0.05. If it's less than 0.05, that means it's really unlikely that that would happen using that distribution here, and so the probability therefore has probably changed. So if it's less than 0.05, you would reject H0 and you would accept H1. If it's more than 0.05, obviously it would be the other way around and you would accept H0. So part C is exactly the same thing, it's just instead of comparing it to 0.05, you're going to compare it to 0.1. And again, if it's less than 0.1, you would then accept H1. If it's more than 0.1, you would accept the null hypothesis. Question 2 brings in a few things from year 12 and also a little bit of the work that we did at the end of year 12, which is like the year 13 topic. So to find the equation of the normal, you're going to need to work out the gradient of the normal and the point that it goes through. So it tells us that the x-coordinate is 5. You would have to work out the y-coordinate by putting 5 into the equation here. And then you're going to have to work out your gradient. So to do that, you're going to have to differentiate this. And this is the product rule because you've got two things times together. So you've got x times by root x minus 1. So you could rewrite that as x minus 1 to the power of a half. So you would say u equals x, v equals x minus 1 to the half. And then you're going to have to differentiate both of those. So if you differentiate this one, obviously you're just going to get 1. To differentiate the other one, it brings in actually the chain rule within the product rule. So to use the chain rule, you just bring the power down. So to differentiate, so you'd bring the half down, make it 1 less, so 1 less than a half is minus a half, and then you times that by what you get when you differentiate the bracket. However, in this case, when you differentiate that bracket, you're just going to get 1, so it actually stays like that. And then you do that times that, plus that times that. So that's going to give you dy by dx. To work out the gradient, therefore, of the normal, if you put 5 into dy by dx, that's going to give you the gradient of the tangent, which we do need, but that's not the actual gradient, that's just the gradient of the tangent. You then need to make it perpendicular to that to get the gradient of the normal. Question 3, stationary points. So again, it's to do with dy by dx, stuff that we did in year 12 earlier on in the year. But again, to differentiate this, it brings in year 13 differentiation really. So you need to find dy by dx and you need to set that equal to 0 because at a turning point, remember the gradient is 0. So to differentiate this, it is the quotient rule because it's a fraction. So you would say u equals x, v equals 9 plus x squared. Differentiate both of those. And then the quotient rule is where you do v times du by dx minus u times dv by dx. So just make sure you're minusing them this time, not adding them like the product rule. And then that goes over v squared. So you would need to do this one times this one minus this one times this one. And then that will go over all of that squared like that. So then to find the stationary points, you set all of that equal to 0. Now remember, when you times the, to solve that equation, you would times by the bottom of it, and then the bottom of the fraction gets times by the 0, and so that kind of gets rid of it all, so it makes it a lot simpler for you. And then you just got to solve that to get the values of x. And determining the nature of them, you have to differentiate it again. And then you would just put in the value of the x coordinate of each of the stationary points. And remember, if the second derivative is less than 0, it is a maximum. If it's greater than 0, it is a minimum. Right, question 4 is binomial expansions. So the power is 8, so you would start with 8c0, 4x to the 0, 1 to the power of 8, plus 8c1, 4x to the 1, 1 to the power of 7. So make sure your powers are adding up to the 8. That should be fine, I would have thought. Part B, working out the approximation. So you set the bracket equal to this bit here, so 1.04. Work out what x is. So just rearrange this a little bit. So you'd get 4x equals 0.04. Divide it by 4, so x is 0.01, and then you substitute that answer into your answer for A. Question 5 isn't actually too bad. So find the temperature of the ball as it enters the liquid. So as it enters the liquid, T would just be 0. So you're just substituting T equals 0 into there. And then finding the value of T for which capital T equals 300. So you set this equal to 300. Now you've got an equation here with e's in it. The only way to get rid of that is to use Lund's. However, you need to get this e part on its own before you can do that. So you'd have to minus the 25, then divide by 400, and then you can Ln both sides. So you'd get Ln whatever this side is equals Ln of this. And when you do Ln e to the minus 0.05t, Ln and e are inverses, so they just cancel out. So it would just be equal to minus 0.05t, and then you can divide by minus 0.05 to work out your value of t. Question 6, so a little bit of mechanics. So we know that a ball's projected vertically upwards with a speed of 14.7, and it's 49 meters above the ground already. So the greatest height above the ground reached by the ball. So the greatest height is going to be when v equals 0. So when it gets to the top here, it's just going to stop for a little bit before it then drops. So you would say, if we're going upwards like this, that u is 14.7. V would be 0 because it's just going to get to the point where it stops for a bit. So v would be 0. It's moving freely under gravity, so because we're resolving upwards, it's going to be minus 9.8 because that's going to be acting downwards. And then you just need to work out S. So the formula for that is this one. Okay, so you need to rearrange that to get your S and put those values in. And just remember as well, because it's the greatest height above the ground, you'll then need to add on your 49 meters as well. The speed with which the ball first strikes the ground. So there's a couple of different ways that you could go about doing this. So just you don't have to do it the way that I would suggest. You could do it a different way, that's fine. So I would probably go from this point downwards, but you can go right from the beginning and do it that way as well. So I would probably say if it starts from here, u equals 0. We know that the distance is the distance that you would have worked out here. I think you should get an answer of 60 if you've done that correctly. Again, A is going to be 9.8, and then you're trying to work out V. So it's going to be exactly the same formula as that one. And then just remember to square root your answer as well, okay? Because you're going to get V squared, so just make sure you square root it there. The total time then from when the ball is projected to when it first strikes the ground. So for this one then, I would probably, again, there's different ways to do it. I'd probably like resolve it downwards like this. So the initial speed, I'm going to do it from the beginning this time. So the initial speed when it goes up is 14.7, but just be careful because I'm going to go resolve it downwards, so therefore this is minus 14.7 for the initial speed. When it first strikes the ground, you've worked out the speed where it strikes the ground up here. If you've done that correctly, you should have got about 34.3. Because we're going downwards this time, I know that A is going to be positive 9.8. And then you're trying to work out, what are we trying to work out? We're trying to work out the total time. So actually you can just use that formula there to work out then the t. Okay, so you can do v minus the u and then divide it by the a, and then that should give you t. Okay, question 7 is a circle one. So given that the point 1,5 lies on C, find the value of k. So in that coordinate, x is 1, y is 5. So substitute those into here. And then you should get an equation that you can solve to work out what k is. And then the coordinates of the centre and the radius, that would just be completing the square. So remember where you've got, if it's 8x here, you halve that to get 4. And then 4 squared is 16, so just remember to take that off. Then do the same kind of thing for your y's, rearrange it, and then you should be able to get your centre and the radius. Question 8, a bit more mechanics. So on this one, it's variable acceleration. It doesn't mention the fact it's constant at all. So therefore, this is going to be to do with calculus, so differentiating and integrating. So I'll just quickly read out the question. So v equals this. Find the distance of p from 0 when p is moving with minimum velocity. So this is an 8-mark question, so there's quite a bit to do. So the first thing is to work out where is the minimum velocity, like what time is that happening at. So the first thing you would have to do is differentiate v and work out where the minimum is. So dv by dt would be 6t take away 4. So like a question that we did earlier, to find the minimum points, you would then set that to 0 and solve it. So if you add 4 and divide by 6, you're going to get t is 2/3. So you want to find then the distance. So if that is your velocity formula here, you would need to integrate that to get your formula for s, and then you can put your value of t into here. Question 9, differentiate with respect to x. So this is year 13 differentiation that we looked at the end of last year. Two things times together, so this is product rule. So u equals x squared, v equals cos 3x. So differentiate them both. And then you do this one times this one plus this one times that one to get dy by dx. And then final one is the quotient rule, because it's a fraction. So you would say u is the top part, v is the bottom part. Again, differentiate both of those. So that was nice and easy. This one you'd have to use the chain rule. So if it's ln of something, it would normally be 1 over that something. So it would normally be 1 over x squared plus 1. And then you times that by what you get when you differentiate the bracket here. So that would be 2x. So remember, when you times a fraction by that, it would just be the top bit. So it would just become 2x over x squared plus 1. So quotient rule, you would then do this one times this one. So it's the v1 first, take away this one times this one, and then that goes over v squared.